In this video, I'm going to be talking about the phase shift of a sinusoidal waveform. Now we have a sinusoidal waveform right here. I'm going to call this waveform in black V1, and this waveform in red, I'll call it V2. These two waveforms are in phase. But what do we mean when I say in phase? You can see that V1 and V2 start at the same point and at the same time along the x-axis. They rise at the same time and they reach their peaks at the same time. They go back to zero at the same time, and in the opposite direction, they rise and reach their peaks at the same time, and they go back to zero at the same time. Whenever a waveform, a sinusoidal waveform, behaves in this way, we say that the waveforms are in phase. They start at the same place, they peak at the same time, they go back to zero at the same time, they peak in the other direction at the same time, and go back to zero at the same time. Now this waveform here is out of phase. Now why do I say that it's out of phase? V1 starts at zero, right here. It goes back to zero right here. It peaks right here, goes back to zero right here, peaks right here, and goes back to zero right here. Waveform number 2, in red, however, starts right here and peaks right here, goes back to zero right here, peaks right here, and goes back to zero right here. Notice also that the peaks are in different locations. And there is a time delay between the two waveforms. Whenever sinusoidal waveforms behave in this manner, we say that the two waveforms are out of phase. They have the same period, t equals t. But even though they have the same period, these two waveforms are still out of phase because they start and stop in different locations. Unlike these two waveforms that start and stop at the same locations. Now, the formula for calculating the phase shift of a time-varying signal such as these is phi, which is the phase shift, equals a delta t times 360 degrees divided by t over the period. Now what's delta t? Delta t is the time delay between the two waveforms along the x-axis. It's the time delay of the two waveforms along the x-axis. And this brings me to the end of the video. If you like the video, give me a thumbs up, like and share, like and share, like and share, and I'll see you in the next video.